I want to look today at finding delta H for a reaction. In particular, we're going to look at the reaction of NH4NO3 dissolving in water. So the equation that we're looking at is taking NH4NO3 solid, dissolving it in water, and getting NH4 plus and NO3 minus. Now, to find delta H, there are two pieces that we're going to need to find delta H. So this is the definition of delta H. It's the Q of reaction, the heat given off or taken in by the reaction divided by the moles. So there are going to be two parts to this problem. We're going to find the Q of the reaction, and we're going to find the moles of the reaction, and we're going to divide one by the other. So let's look at finding Q first. We want Q of reaction. Q of reaction is not something we can measure directly. We can only look at what the reaction does to the surroundings, the solution that's around it. So we're going to measure the heat of the solution first. So this is the relationship we're going to use to find the Q of solution. It's the mass that's being heated times the specific heat times delta T. Well, let's look at these things. Let's start with mass. It might be tempted to say, oh, I've got my mass, 1.25 grams of NH4NO3. But it's not just the mass of the water, of the solid that's gaining heat. The water that's dissolved and also is gaining or losing heat. So we have to consider the mass of both of these, the NH4NO3 and the water. So let's find the mass of the water because I gave you milliliters. So 25.0 milliliters times 1 gram per 1 milliliter gives you 25.0 grams. That's the mass of the water. So the mass of the entire solution that's being heated is the mass of the water plus the mass of the NH4NO3 is 25.0 grams for the water plus 1.25 grams for the NH4NO3 is 26.2 grams. So that's our mass that goes in right here. Specific heat, I'm giving you 4.18 joules per gram. Delta T now. Delta T is always final temperature minus initial temperature. So our final temperature was 21.9. Our initial temperature was 25.8. So when I plug this into my equation, 21.9 comes first, the 25.8 goes last. So the mass, 26.2, CS, 4.18, and delta T, 21.9 minus 25.8. When I plug that into my calculator, I get Q of solution equals minus 430 joules. Now you might be tempted to say, oh, I can plug this into delta H right now because I've got the heat. But remember, we have to do two things. We have to get from the heat of solution to the heat of reaction, and we need to go from joules to kilojoules. So how are we going to go from solution heat to reaction heat? We remember the relationship that says Q reaction is the opposite of the Q solution. So there's a negative sign in front of the Q solution. If the solution gains heat, the reaction loses exactly the same amount of heat. If the solution loses heat, the reaction gains just as much heat. So that's what we're going to do. So applying that to this case, we get, I did not mean to do it this way, but we get a negative of a negative 430 joules equals plus 430 joules. That is the Q of the reaction. Now you'll also remember we said we need to have the value of Q of reaction in kilojoules, not joules. So let's look at that right now. This is a metric conversion of the kind you did for your first exam. 430 joules times 1 kilojoule per 1 times 10 to the third joules gives us 0.430 kilojoules. So this would be on the top part of our delta H equation. Now we need to find the moles. And this is a standard mole calculation like you found many times before on many other problems. We're finding the moles of NH4NO3. We don't care about the moles of water. It's the NH4NO3 that's giving or gaining heat. And we have 1.25 grams of it. Remember, we only care about the moles of NH4NO3. So 1.25 grams times 1 mole per 80.1 grams, that's the molar mass, gives me the moles, 0.156 moles. Now I have the Q, my heat in kilojoules, and I have my moles. I'm ready to just plug into my delta H equation to find delta H. So, and I've got the wrong number there, don't I? Remember, it's kilojoules, and I found kilojoules is 0.430, so I need to change that to 0.430. So it's 0.430 kilojoules, the number we got there, divided by the number of moles we got here, 0.156. 2.7 times 10 to the 4th kilojoules per mole is the value of delta H for this reaction.